Here we have an interesting case with an 8-inch wafer that has a thin layer of tape on the top. We are interested in measuring the total thickness of the wafer, including the tape, the thickness of the tape, and the thickness of just the wafer itself. However, due to the refractive properties of the tape layer, measuring just the wafer itself can be a challenge. The system uses dual-sided sensors, one that measures from the top and one from the bottom. As the top sensor measures through the tape layer to the top surface of the wafer, the light gets refracted by the tape, thus affecting the light that bounces back to the sensor, causing the wafer thickness measured to be much higher than it actually is. In order to accurately measure the wafer, we perform two separate scans, one of the total thickness including the tape, and a second of just the tape layer itself, while factoring in the tape's refractive index. From these scans, we can then have A-scan automatically subtract the tape thickness from the total thickness, resulting in the real actual thickness of just the wafer. We have a program set up here that measures 21 discrete locations across the wafer. The amount of locations can be configured easily depending on if you need more or less data points. The overall program sequence is broken down into 3 tasks. The first task will use the top and bottom sensors to measure the overall thickness of the wafer and tape. The second task will measure just the tape layer itself at the same location as before, with the refractive index already factored in. The third task will then take the overall thickness and subtract the tape thickness out, thus leaving us with the actual thickness of the wafer. When you start the program, you can select which areas of the wafer you want to scan in case you want to do less scans or look at specific areas only. In this case, we will measure every location. Next, the system will perform a fiducial check on the wafer flat in order to align itself. After this, the system will scan each area in sequence. In this demonstration, however, the scans have already been done and the results are simulated using previously scanned data. After the system is done scanning, the results are saved automatically in a fully customizable layout, typically as a text, CSV, or XML file, and we are provided with a quick overview of the results. We can click through each individual scan if you need a closer look. The software comes with built-in SPC charts where you can set different control limits in order to quickly identify any measurements that are bad or out of spec. The results can easily be exported as a heat map, showing a quick visual representation of the thickness distribution across the wafer. This can be very useful for putting together reports or presentations.